Hi friends, in this video I'm going to talk about differentiation of a product. Suppose you are having a function f of x equals to uv. Now in this case you are having two functions multiplying each other, and whenever you are having a function, two functions multiplying each other, you are going to use product rule formula. And if you are given y equals to uv, right, which is also the same as what f of x equals to uv, then the y by the x is going to be u dv dx plus v du dx. So basically what you are going to be using here is actually this formula. This formula is actually what you are going to be using whenever you are asked to differentiate using product rule. Now look up. In order for you to identify product rule is just a scenario whereby you have two functions multiplying each other, be it trigonometric function multiplying each other. For example, let's say you have y equals to sine x cos x. In this case, you have sine x as a function and cos x as a function. That means you have two functions multiplying each other. Or let me just say you have a scenario where you have y equals to exponential x cos x. In this kind of situation as well, you can see this is u and these are what v. So in this case, you're having two functions multiplying each other. So basically, whenever you have two functions multiplying each other, you are going to simply use divide the x equals to u dv dx plus v du dx, and that's actually the product rule formula. So this product rule formula was actually proven using first principle. So in this video, actually, I'm not going to show you how to prove it or how to derive the product rule formula, but I'm going to show you how to apply the formula to solve numerous questions as far as differentiation is concerned. Now let's say we have the first question here. Let's say we are given y equals to x sine x, right? Suppose you are given y equals to what? X sine x, and you're asked to find dy by what? By the x. You're asked to find y by the x, given that what? Your y equals to what? X sine x. So first thing is that you guys need to take note of this. We have x here and also we have what? Sine x. In this case, this o function here, or let me just say o expression here, is also the same thing as what? Writing y equals to uv. Y equals to uv. U is the function and v is also what? A function. This y is actually a function that depends on what? On uv. So this uv in turns depend on the function of what? X. So now in that case, now I'm having y equals to what? Sine x. Simply I can say let u equals to x and v equals to what? Sine x. That is, this is my v and this is my u, right? So now in order for me to find the derivative, now in order for me to find dy by what? By dx. Now look up, dy dx, if you recall, it is u dv dx. That means I need my dv dx. Since this simply means I'm differentiating my function v with respect to what? X. Then you locate the value of v. This is v. V is sine x. Then you're going to differentiate your v with respect to what? X. That means you're going to have dv dx. Dv dx in this case is going to be what? Cos x. It is standard derivative. That is, whenever you have sine x and you're asked to find the derivative of sine x, it's simply what? Cos x. So after that, then the next thing is that then plus v, our v is actually what? Sine x du dx. That means we are asked to differentiate what? Our u. That means you are going to be differentiating u with respect to what? X. That simply means you are asked to find du dx. And du dx in this case, look at this. This is the power of x here is what? Is 1. Then you bring it down using power rule. Then you're going to have 1x power 1 minus 1. So this is simply 1x power what? 0. Anything is power 0 is actually 1. So that's 1 times 1, which is actually the same as 1. So that means in this scenario, your du dx is equals to what? 1. So all this expression, I'm going to fix inside what? This formula. So putting it into this formula, I'm going to have dy by dx to be equal u. What's your u? U is x. Then multiply by what? Dv dx. Dv dx is what? Cos x. Plus, what's our v? Our v is what? Sine x. Then followed by du dx. What's our du dx? That's what? 1. We're going to have 1. Then I can simplify this further. I'm going to have x cos x plus sine x. So that's just it. So whenever you are given a function y equals to x sine x and you're asked to differentiate it, you should be able to see that, okay, this is two functions multiplying each other. This is variable function and this is what? Trigonometric function. So they are multiplying each other. Simply you're going to use what? Product rule, and you're going to get a final answer to what? To be this, as far as this one is concerned. So now I'm going to solve another example for you guys. Suppose we are given, let's say you are given function f of x, or you simply say y equals to what? Let me just say we have something like s squared exponential 2x, and you're asked to find the derivative of what of this function. So what it actually means is that, look at this very well. You have even one function here multiplying what exponential function. This is actually a variable function, or you simply say polynomial function multiplying what a variable exponential function. So in this case, that means I have to find what derivative using what product rule. Why? Because I'm having two functions multiplying each other. Now let's go look up. Here we have what this is going to be our u and this is going to be our what our v, right? So that means simply I'm going to have my u to be equal to what s squared and my v to be equal to what exponential 2x, right? Now what do you think I'm going to do in this kind of situation? Now look up, according to this formula, whenever I'm having two functions multiplying each other, I'm having y equals to uv, then if I'm asked to find the derivative of what of y, I'm going to use this formula. Then our u is simply this, our v is simply this. Then what do I need? I need dv dx. Where's my v? This is my v. Then I ask to differentiate my v with respect to what x. So differentiating this is another scenario, another case entirely. Look at this. We're having v to be equal to what exponential 2x, and I'm asked to what differentiate it. Although directly, if I want to go direct, I can actually say this is actually the same thing as what v prime is equals to 2 exponential 2x. But I'm going to explain how I get 2 exponential 2x right now. Now look at this. I'm having v equals to exponential 2x. I can actually replace this with what? With another variable. I can say let p equals to 2x, right? In that scenario, what's going to be my derivative of what? Of p. So here I'm going to have the p dx to be equals to what? 2. If I differentiate this, I'm going to have it to what? 2. Right? Then after that, I'll come back to this. Since I'm having v equals to what? Exponential 2x. 2x is actually p now. I'm going to have what? P. Then in this case, I'm going to differentiate my b with respect to what? P. That's dv dp, which is what? Exponential p again. So whenever I'm giving something like this, exponential u, if I'm giving, let's say, exponential x, if y equals to exponential x and I'm asked to what? Find the derivative of what? Exponential x is still what? Exponential x. If I'm giving y equals to what? Exponential u, I'm asked to find the derivative of y with respect to what? U. It is still what? Exponential u. So in that scenario, dv dp is still what? Exponential what? P. So in that case, I can now recall that what? I'm having my p to be equals to what? 2x. So that means my dv dp is what? That's exponential 2x. Now, actually, what do I need to calculate for? What am I asked to find? I'm asked to find the derivative of what? Of dv with respect to what? X. So in that scenario, I've actually encountered two more derivatives. Now look up, I'm having this one, dp dx, which is the first one, and also I'm having what? Exponential 2x, which is what? The second one. Now enough for me to guess dv dx that I'm actually looking for. Look at this. I'm going to do this I'm going to use one kind of formula like that. That's function of function. But now look up, I'm having dv dx. This is my dv dx, right? Dv dx. Then I'm going to simply multiply this guy by this guy, which is what? Dp divided by dx multiply what? This again, dv divided by what? Dp. Now look at this very well. If this cancels this, I'm going to have dv dx back, which is this guy. Check it now. So in that scenario, I'm going to have dv dx equals to dp dx. My dp dx is what? Is 2. dv dp is what? Exponential 2x, which is what? Exponential 2x. So that means whenever I'm giving v equals to exponential 2x and I'm asked to find the derivative, I will simply bring these two down here. So the derivative is going to be what? 2 exponential 2x. So that's what I actually need. Then come back to this guy now. I'm going to find what? dv dx. dv dx is going to be what? That's going to be 2 exponential 2x. Exactly. And after that, I need du dx. So du dx in this scenario is going to be what? That's going to be 2x. As you can see. Now, I just need to put this expression into this what? Formula. So in that scenario, I'm going to have my dy by dx to be equals to u. My u is what? Given as s squared. Then dv dx. dv dx is what? 2 exponential 2x. Then followed by plus v. What's my v? My v is exponential 2x. Then followed by what? Du dx. My du dx is what? Du dx is what? 2x. Right? So I can actually go ahead and simplify this further. I'm going to have this to be divided by what? By dx equals to what? S squared 2 exponential 2x, right? Then plus 2x exponential 2x. Now look at this very well. The common factor here, there's something that is common here. And what is common here is actually 2x exponential 2x. I can actually factorize this out. Then factorizing 2x exponential 2x out, I'm going to have this to be what? This is going to be 2x exponential 2x into brackets. Here I'm going to have x plus 1. Because by the time I actually use this guy to open this bracket, I'm going to have this multiplied by this is going to give us 2x squared. right? Then I'm going to have x similar to x. Then this multiplied by this is going to give me what? This back. So that's just the answer. Now, one thing is that I need to show you guys how to actually go ahead and what and differentiate using product rule. That is the short trick that you can actually use, because this one is actually a long method. But let's say you are inside the exam hall and the exam you are asked to write is actually that you are given to write is actually, let's say, it's theory. Now that's when you can actually go ahead and use all this formula of it. But let's say you are dealing with MCQ question, there's no time, you are actually doing a computer-based examination, so you have to look for a trick to get it very fast. Now listen, let's just go. The first one that we actually did here is actually x sine x. Now let me just use short trick to that. I'm having y equals to what? X sine x, right? Now the short trick is that I'm going to hold one, differentiate one, plus when I hold the other and differentiate one. That's actually what this formula means. Now look up, this is y equals to x sine x. So in that case, if I'm asked to find the y by the x, the y by the x is going to be what? I'm going to hold this x. If I hold x, I differentiate sine x, that's going to be what? Cos x. Plus when I hold what? Sine x, I differentiate x, which is what? 1. If I simplify it, I'm going to have s cos x plus sine x. Very, very fast. Look at this. We have the same answer as this. X cos x plus what? Sine x. Instead of using formula, you can simply use this short trick. And look at this from the formula. We have divide the x. Whenever you're giving y equals to uv, and you ask to find divide x, you are going to hold u. You hold u, you differentiate v. Plus when you hold v, you differentiate what? U. That's what the formula means. Now let's apply the same thing method on this guy. So you're having y equals to what? S squared exponential 2x. In that scenario, you are asked to find the y by the x. The y by the x is going to be what? I'm going to hold this. I hold s squared. Differentiate this exponential 2x. That's going to give me what? 2 exponential 2x. Plus when I hold exponential 2x, I differentiate this guy. I'm going to have 2x. Then I can simply simplify further. I'm going to have this to be equal to what? 2s squared exponential 2x plus 2x exponential what? 2x. What can I factorize? I can factorize what? 2x exponential what? X. Factorizing it out, I'm going to have 2x exponential 2x into bracket what? X plus 1, which is also the same thing as this. So that's just it. So that's just a simple way of calculating of solving for duration of products. So and that's just it. So if you enjoyed this video, please don't forget to like, share, and don't forget to click on the notification button as well. Don't forget to subscribe at the same time. Thanks for watching.